Hi there, and welcome to the first of a series of talks I'm going to be given under the rough title of Exploring the Universe from the Isle of Man. And the first of these talks is entitled Our Place in Space. And we're going to look at the Earth and the other planets and objects in our solar system over the course of the next 15 to 20 minutes. When we look at the solar system, there are a total of 8 planets in our solar system. There used to be 9, and we'll come on to that a bit later. And the first of the planets in our solar system as we come out from the Sun is, of course, this small planet Mercury. Mercury orbits the Sun in just 88 days. So if you lived on Mercury, you'd have a birthday every 88 days. Wouldn't that be some fun? You'd also get Christmas Day every 88 days. But very, very small, no atmosphere, a small rocky planet. And although there have been spacecraft sent to Mercury, it's not an object we're probably going to go back to in the very near future anyway. The next planet out is often described as a twin of the planet Earth, and this is of course the planet Venus. The comparison, however, apart from size, is totally wrong, because the surface temperature and the surface conditions on Venus are very hostile indeed. The temperature is hot enough to melt lead, the atmospheric pressure would squash you into a grease spot, and it rains sulfuric acid rain. And just to cap it off, there's winds about 300 to 400 miles an hour, much windier than we get here in the Isle of Man, so not a place to visit for your holidays anyway. The Earth, of course, needs no demonstration or whatever, because it is just a beautiful object. Here's the Earth. We're looking in particular at the continent of Africa up here. Australia's over here, and a hi to Olivia, I know, watching from Melbourne in Australia. And the Earth was first seen from space by the Apollo astronauts back in 1968 and the subsequent missions to the Moon. This was the first time we saw the whole Earth from space with human eyes, and it really made us realise what a beautiful but fragile place it is. And the growth of global consciousness probably owes its origins in a number of ways to the pictures, these wonderful pictures we got from space those years ago. The next planet out is the planet Mars, and Mars, of course, is a fascinating object because we believe Mars used to have water. It used to have a much bigger atmosphere than it does now, and we believe that life may well have evolved on Mars. Not little green men or anything like that, but we believe that life evolved on Mars, but then the conditions on Mars changed and life ceased to exist on that planet. This is a theory, we haven't proved it yet, but we are sending spacecraft to Mars with an express aim of trying to discover if life did evolve on Mars and why did it cease to carry on existing. That's one of the great quests for the planetary scientists, and we're going to Mars, as I say, later this year with a number of spacecraft which will get there in spring of next year, and hopefully we'll get to see and learn more about Mars and possibly discover if there was ancient life on Mars many years ago. The next planet in our solar system is the huge planet Jupiter. And the huge planet Jupiter is what we call one of the gas giants. It's the biggest planet in our solar system. It's got these atmospheric bands you might just be able to see on the screen. It's also got a giant red spot. This giant red spot here is an atmospheric disturbance, an atmospheric storm that has been going ever since Galileo first turned the first telescope onto the planet Jupiter back in the early 17th century. Now, Galileo also discovered that Jupiter has got a series of moons. They're named appropriately enough, the Galilean moons. And on this picture you can see the shadow of one of them. The shadow of this moon here on the surface of Jupiter is roughly the same size as our planet Earth if you were to draw it to scale. That just gives you some idea how massive and huge this planet Jupiter is. The last of the naked eye planets is the planet Saturn, and the planet Saturn really is the most beautiful planet in our solar system, probably after the Earth. When I was a young boy, we thought Saturn was the most beautiful, but since we've seen the Earth in space, I think we've accepted that the Earth is the most beautiful. But Saturn has got this wonderful ring system, and this ring system was first seen by Galileo when he first used his primitive telescope in the early 17th century, and he knew there was something odd about Saturn. Saturn's rings do alternatively tilt up and down as we get our viewing aspect from where we are on the Earth. And as they go through what we call the ring plane, the rings pretty well disappear. And Galileo was looking at it when the rings were edge on. He was looking through the ring plane, as it were, and this meant that he couldn't really work out what the ring system was. It was to take another 50 or so years before Christian Huygens actually worked out what the ring system was, and we learned all about this wonderful planet and this beautiful view. And if ever you want to get that wow factor in astronomy, show someone the planet Saturn through a telescope, and when they look at it, they'll go wow. And as an astronomer, that is the biggest kick you ever get, because showing people the wonders of our universe, and in particular Saturn, as I say, it really is one of those wow moments. Carrying on, the next two planets we've got in our solar system are not visible to the naked eye. Uranus just about on occasion, but very rarely. I've seen it with the naked eye myself on a couple of occasions, but you've got to be very, very sure where it is, and basically watch it for a couple of nights and see if it moves, and that's how you can work out what it is. It is so far away, we need telescopes to see it in detail. And if we're fortunate enough to get a spacecraft there, which we've done that just the once with the Voyager 2 spacecraft in 1986, we were very disappointed with the features on the disk of Uranus, because it's a featureless, it's just basically the top of the gas giant of Uranus. But the moons of Uranus are fascinating objects. The moons of Uranus seem to have been shattered into thousands of pieces and reassembled, in particular the one Miranda. But the other odd thing about Uranus is it has a tilt. Most planets have an axial tilt. We have a tilt, and I'll come back to that a bit later on. But the tilt of Uranus is 98 degrees. This means that Uranus rolls around the solar system rather than rotates on its axis upright. Really an odd place to be, or an odd place to get to. And the final planet in our solar system is, of course, the planet Neptune. Neptune too has an atmospheric disturbance called the Great Dark Spot, but this has disappeared. Since Voyager flew past in 1989, we know that the dark spot has disappeared because of the observations from the Hubble Space Telescope and other observatories that have been able to see the surface of the, well, not the surface, but certainly to see the disk of the planet Neptune. So there we have it. Those are our 8 planets, the 8 planets in our solar system, and they're all roughly spread out in a line. This line, we call it the plane of the ecliptic, and this means that the planets always pass through the same constellations in the sky, and that's where we get the signs of the zodiac from, which we have our own birth signs and everything else. But this is because all the planets religiously go round the sky in the same path. There is a slight variation, but more or less they go on the same line. Incidentally, the moon and of course the sun also pass along this same line, and we call this line the ecliptic, and the signs of the zodiac are the constellations within the signs of within the ecliptic, or on the ecliptic, that we can see from time to time as we go through the year. So, turning back to the size of the planets in a bit more detail now, this is of course a photograph or an image of what the size of the planets are like. The sun, of course, absolutely huge, much, much bigger than even the giant planet Jupiter. Jupiter, here we've got Saturn without the rings, then we've got Uranus and Neptune, here we've got the Earth, then we've got Venus, then we've got Mars, then we've got Mercury, and just at the tip of this little arrow here, we've got the planet Pluto. And if you look at those planets on the bottom first, these are what we call the rocky planets. They are made principally of rocks. And the inner planets, Earth, Venus, Mars and Mercury, are all made roughly of the same sort of rocky material. Pluto is a bit of an exception in lots of ways. In fact, poor Pluto got demoted from planetary status a few years ago, and I'll come on to that in just a moment. So those are the inner planets, the rocky planets, excluding Pluto of course, but these are the gas giants. All the planets are actually on this slide, but the smaller ones, the inner planets, are down here. These 4 gas giants are made up of lots of gas, principally hydrogen and helium, and they really are very, very big in comparison to the size of the smaller planets down at the bottom here. But I mentioned Pluto, and poor Pluto was downgraded back in 2005. Just why, I'll let this little video tell you about it now.
Pluto was discovered by Clyde Tombaugh in 1930. It is not considered a planet anymore because in 2006, astronomers of IAU gave a new definition to the word planet. According to the new definition, a planet is a celestial body, which is in orbit around the sun, is spherical in shape, and it has cleared the neighborhood around its orbit. What does this mean? It basically means that using its gravity, a planet should have removed asteroids and dwarf planets out of its path, thus cleared its neighborhood. Now, Pluto is in orbit around the sun and is spherical in shape. But since Pluto's neighborhood has many other objects and it has not cleared its neighborhood, it is not called a planet anymore.
So as a result, Pluto was downgraded and is given the official status of being a dwarf planet. This decision was quite controversial, and indeed is still quite controversial. And I personally think that Pluto should still be a planet since it was discovered in 1930, but the International Astronomical Union, who control all the decisions and all the naming and everything else in the solar system, decreed that Pluto was not a planet. It is a dwarf planet. It is one of a number of dwarf planets. We've got another dwarf planet not far from us in the asteroid belt called Ceres. That is the nearest dwarf planet to us. And then out beyond the orbit of Neptune, we've got Pluto, we've got Eris, we've got Sedna, we've got Quaoar, Makemake, and a few others. We do believe there may well be another planet beyond the orbit of Pluto, much bigger than that, and we think it might be the size of the planet Neptune, but we've yet to discover it. We think we've discovered it mathematically, but we can't find it. It's so far away and obviously not easy to observe, but more of that hopefully in the next few years. But the International Astronomical Union, of course, this is the body that was founded in 1919, and the principal job of the IAU is to basically promote the subject of astronomy worldwide. It's an internationally accepted organisation, a bit like the United Nations of Astronomy, and they look at the education, development and everything else through international cooperation. And they made this very controversial decision back in 2005 that Pluto should be downgraded to become a dwarf planet. It's one of the Kuiper Belt objects, but it is now officially a dwarf planet. As I say, the story itself will rumble on for many more years to come, but the IAU have the last word because they are the international authority on that. And last year, in 2019, to celebrate their anniversary, their centenary, the IAU announced an international competition for all the countries in the world. And this particular slide is showing the UK's competition. The IAU invited all the countries of the world to name a star, which had previously not been given a name, and also a planet that had been discovered around that star. Well, the competition was launched throughout the United Kingdom. The Isle of Man requested permission to enter the competition as well. Although we're not part of the UK, we are a separate country, but we were able to enter through the UK name. And I'm delighted to say, for those of you who didn't know already, that the Isle of Man entry, the entry from the Cronkyberry Primary School, just up the road here from where I live in the Isle of Man in Onken, and they were actually the winners. They were given the honour of naming this star and this planet. The name of the star, this is the school here, they were very delighted obviously to get such international recognition, and forevermore this star and this planet will have a Manx name. The name of the planet is Crunluck and the name of the star is Gloas. These words come from the Manx Gaelic. The Manx Gaelic for Gloas means to shine like a star, and Crunluck, the planet, means to orbit like a planet around its star. Fantastic honour for Cronkyberry School and of course for the Isle of Man as well, so well done to Cronkyberry. But I talk about exoplanets, or extrasolar planets to give them their proper name, and what exactly are we talking about? We're talking about stars which have got planets around them. Up until 1997 we didn't believe there were any stars had planets. We thought they might have, but we hadn't seen any. Well, now through the obvious means of using space exploration, which can really give fine-tuned measurements, they were able to find planets around other stars. And as I say, back in 1994 there were none whatsoever. The first one was discovered late that year, and in 2011 we've discovered up to 687. Well, since then, only a few days ago at the end of March, the sum now, or the figure now, is 4,141 confirmed exoplanets around other stars. Fantastic number, mainly due to the Kepler Space Telescope and now the new TESS Space Telescope. And what is important is we've discovered 4,000 definitely. There are another 5,000 that we think exist that haven't been confirmed yet. They will almost probably all get confirmed, and we'll be up to 9,000 and probably 10 in literally before the end of this year. Would not surprise me. But what is a fascinating fact is we've also got 3,072 planetary systems. This basically means there's 3,072 stars which have got planets, more than one planet on a number of occasions. And this discovery means that planetary formation is not rare as we used to once think. We now believe planetary formation is quite common in solar systems or throughout the Milky Way and the universe. And we are on the verge of discovering smaller planets like the Earth in places in the planetary orbits where water can exist on the surface, which is one of the precursors, one of the most vital ingredients we need for life to exist on another planet. Watch this space, very exciting, and it's growing literally. This number is growing all the time. Only a few weeks ago, beginning of January, I looked at this figure, just went over the 4,000 at the beginning of January. 3 months later, we're up to 4,141. It's amazing, and you need to check it. Just go onto the NASA website, Exoplanets website, NASA Exoplanets, and you'll get the latest information. But you know, when we look at our solar system, let's just come back and take a bit of a breather from all that heady stuff about exoplanets. When we look at the actual planets in our solar system, and we look at our sun, just how does the sun compare in size to some of the other stars that we can see in the night sky? So this little video now is going to just give you a comparison. To start off, we're going to look at the moon, and we're going to compare the size of the moon to our planets, and then from there we're going to look at some of the sizes of some of the other stars. So as I say, we'll start off with the moon. So here we've got the moon compared to the size of the planet Mercury. And then we'll compare the size of Mercury to the planet Mars. And then we'll compare Mars to the size of Venus, and the Earth, which I've said before, are roughly the same size. Then we've got the smallest of the gas giants, which is Neptune. And then we've got Saturn. Without its rings, it wouldn't fit on the slide otherwise. And then we've got the giant planet Jupiter. And then, coming up behind them, you can see the huge size of our sun. But our sun is quite small compared to some other stars like Sirius, like Pollux, the principal star in the constellation of Gemini, like the star Arcturus, the principal star in the constellation of Boötes, Aldebaran, the eye of the bull in the constellation of Taurus, Rigel, the bottom of Orion there, and then we've got some other stars as well. The Pistol star, which is a long way away and it's not a principal star in the constellation, Antares in Scorpio, Mu Cephei, which is the constellation of Cepheus, which is easily visible in the night skies. And then the biggest star we've got is VY Canis Majoris, one of the stars in the constellation of Canis Major, the big dog. Now if we were to manage to get to that star, and there's the size of the Earth compared to the size of this star, just how long do you think it would take you to fly around it in an aeroplane? Well, if you imagine an aeroplane travels about 900 kilometers an hour, if you could carry on flying without refueling, it would take you 1,100 years just to fly around that star once. That makes you realize just how big that star is. And again, I want to stress to you the fact that the stars, they may all look like points of light in the night sky. Go out and have a look. They all look like points of light, but some of them are much, much bigger than our sun. And to be fair, some of them are much smaller than our sun. But the size of the stars does vary. What does change a lot as well is the power from them. Some of them are very bright, some of them are quite dim. Those that are nearest to us, obviously will be more clear because they're bright. They seem brighter because they're near, but some of them far away are still very bright because they're so very, very big. So let's come back to the sun. Let's put the sun onto my screen here, and this is the size of the sun. And if we draw the Earth to the same scale, the Earth is about that big. You can just see how small it is in compared to the giant disk of the sun. Of course, the Earth and the sun are not just this far apart. The distance is actually much, much further. So I'm going to keep the sun at that size, and I'm going to move the Earth off to the right here, and we're going to keep pressing my button until it reaches the right spot. By which time you'll all probably be fast asleep, because I'm going to have to press my button at least 60 odd times. So we'll just do it once more. And then let's make the Earth a little bit bigger again. Let's blow the Earth up in size a bit so we can see it more clearly. And if the sun was still visible on this chart, it would be way, way down there, 65 times the length of my screen down there, but it would be the size of my house. And I don't live in a bungalow, so you can see from this example just how big the sun is compared to the size of our Earth. And the distance, the real distance, is 150 million kilometers in that direction, or 93 million miles. The Earth, of course, spherical. It's called a planet. It is a planet. It fulfills all the criteria we needed to define a planet, and it orbits the sun, and it's got a tilt. And because it's got this tilt, I'll come back to that in just a moment. But the Earth very easily gets illuminated by the sun. The side that's facing the sun gives us our daytime, and the side at the back of the sun, of course, is the darkness. So when the sunlight comes onto the surface of the Earth, we get this period of day and night over a 24-hour period, which is the time it takes the Earth to rotate on its axis. But as I've already mentioned, the Earth has got what we call an axial tilt. And this axial tilt, this is the tilt of the Earth, is actually about 23.5 degrees. Incidentally, Mars has got the same axial tilt. It's actually 25 degrees, not 23, but it has the same axial tilt. And this tilt is responsible for giving us the seasons. When we look at this picture here now, this image, the sun is shining and the southern hemisphere is pointing more towards the sun than the northern hemisphere. So as a result, it is now the summer in the southern hemisphere. So if we now take the Earth right round the sun to the other side, now the northern hemisphere is closer to the sun and we get our northern hemisphere summer. And that's why we get the seasons, and that's why we get the cycle of life we get on the Earth, and that's one of the features we get on the Earth. So day and night and the seasons are all due to the Earth's position and of course its axial tilt that I mentioned just a moment ago. So with the sun being 150 million kilometers that way, we have got another object a bit closer to us, and this is of course the moon. And the moon is not that close to the Earth, it's a lot further away than that. Unfortunately, I can actually make the moon go away to one side, the Earth go to one side, and we can actually get the moon and the Earth on the same slide. There's the Earth, and to scale, distance and size, there's the moon. And it would take you, in a spacecraft, the Apollo astronauts back in the 60s and 70s, it took them 3 days to travel all the way from the Earth to the moon, and of course 3 days to come back. It's a long way away. Nothing like the distance to the sun, but it is a long way away. And great credit and everything else to the astronauts for doing that. And that will be the subject of my next talk I'll be putting on this site very shortly. When we go back to the Earth, to this beautiful blue marble that we talked about later, you can almost see this beautiful effect of what we get to see in the sky. We've got the clouds, we've got the land, we've got the sea, and it really looks a beautiful planet from the distance of going out into orbit and beyond. The moon, on the other hand, is a very hostile, barren place. There's nothing at all on the moon of interest other than the features on its surface which we look at from the Earth. And we went there to the moon, and again I'll be talking about that a bit later on, but the moon is a fascinating object even though it's a dead world. It's 380,000 kilometers or 250,000 miles from the Earth, and it is about 3,000 kilometers in diameter. It also orbits the Earth in 28 days, and in orbiting the Earth in 28 days, it also spins on its own axis in 28 days, which means we only ever get to see one particular part of the surface. And that is why we only see the same side of the moon. But, myth, don't believe everything you hear. There is no such thing as the dark side of the moon. The dark side of the moon is a myth. The moon is alternatively light and dark on both sides. We see the full moon like this. The moon is fully illuminated by the sun. The far side of the moon now will be in complete darkness. But when we come round to a new moon, when we can't see the moon, or a very thin crescent of the moon, the far side of the moon will be illuminated and the near side will be in darkness. So there's no such thing as the dark side of the moon, and if you've learned nothing else from this talk, I want you to remember that. But the moon, of course, been seen by ancient civilizations as an object of fascination throughout many, many centuries. And some people can see the man in the moon. This one, a bit different this one. I've never worked out whether this is a telescope, a shell, or maybe a, I don't know, something stuck in his eye. It really is a bit weird, but we can see his eye and his nose and his mouth here. Other civilizations see the moon as a rabbit. Now you might realise that this picture is turned 90 degrees, and that's why the Chinese and the Southeast Asian people tend to see the moon as a rabbit. We don't, we see it more in this shape. We see these are the rabbit's ears down here, but because it's tilted, we don't quite see it as a rabbit as much as they do. But they see it as a rabbit. And then of course we've also got the kiss in the moon, and I can never see the kiss in the moon, but this picture does show it quite clearly. So go out and try for yourselves when the moon is full. The moon, here we've got the hair of the man, here we've got his eye, his nose, his mouth, his chin, and there's a lady here with long hair giving him a kiss on the cheek. How romantic. Go out and look for yourself, see if you can see it. Finally, on the moon, I just want to mention the fact that the moon does show these phases. I mentioned that just a moment ago. It also brings us the tides on the Earth, but that's another subject in its own right. But when the moon is here and the sun is over here, basically we will not see the surface of the moon because it's in darkness. When, however, at full moon, the moon is completely illuminated by the sun, we get the full moon. and in between we get the first quarter, the last quarter, the waxing moon and the waning moon. But rather than just show you in a diagram, how about I show you the moon's phases literally in 2 seconds. Here we go. There we go. That is the moon going from new to half to full very, very quickly, literally in a couple of seconds, just the wonders of computer science. So I hope that's been of some interest to you all. I hope you've enjoyed it, and I do hope you join me for my next talk, which will be on the subject of Man on the Moon, which will be on this site in a few days' time. Thank you for listening, and do give me your comments on the feedback. Bye.